Okay, so I'm going to do a quick introduction. My name is Megan Joseph. Some of you might have seen me in your office, or you might have worked with me on some of your projects. I am the architectural rep for the entire Southeast. We deal exclusively with architects and engineers, and then we have a group of sales teams that work directly with installers and our distribution side. Today's presentation is going to be how to avoid most common rolling door RFIs. Um, Wendy has volunteered to answer questions and read them for me as we go along. So if you come to a point in the presentation that you have a question, type it in. I'm happy to answer those as we go along. On the original presentation that you were given, I know my contact information wasn't on the last slide. So when we get to the last slide, if you would like to take a screenshot, my contact information is now on there, my phone number and email. So if you have questions after the fact, if you would like a presentation in your office, please feel free to email me. Or if you like project assistance, we do offer that. As architectural reps, we do our own CAD drawings and write our own technical specs for our architects. So that is definitely a benefit of what we do. So we are going to get started today. This is for one HSW credit. This is just stating that Cornell, Cookson, and Clopay were registered with the AIA, as am I, to give you one HSW credit. Today's presentation, and this is the second time I've done it, so if my timing's off, I'm going to be looking at it. So if I speed up during part of the presentation, it is because I am running out of time, but this is the second time I've actually done this. Yesterday was my first. So we're going to learn about locking options for rolling doors. And we are going to go over just a few things on sectional doors. I know this is rolling door RFIs, but we will go over some of the main things that I see on sectional doors as well. We're going to go over operators, covers, and electrical options. When we're talking about electrical options, it's going to more pertain to those UL 325 and obstruction detection, high cycle construction, finish options, operable wind load versus standard wind loading that we see for any of our architects here in Florida, designing appropriate mounting and support. You know, originally you got one presentation and I updated that one because there was about 30 slides on mounting and it seemed like an overkill. So we have updated that. That original one was about 12 years old. Firewall construction. So we will go over a lot with fire doors and appropriate, specifying the appropriate fire door closing systems. So we're going to start out with common specified options that aren't really appropriate for certain applications. And we'll start out with this picture here. We have come a long way from this in the industry as far as this is an operator cover. So anytime that you have a door, a rolling steel door that is 8 foot or under, typically you will have an operator cover. This is going to cover any pinch points that anybody could reach. In these photos on the right hand side, you can see here that this is a conveyor belt of some sort. And this big bulky thing is your operator cover. Now, not all manufacturers still use these bulky ones. We've come a long way since then. We'll have these a little bit smaller and fit more tightly to the operator. In this particular situation, you've got a wire coming down here, and then you have this obstructing a view, and it is not really going to be appropriate for this particular application. On the left-hand side, I actually don't hate this application because it's kind of making an awning over this man door, but still you can see how intrusive that operator cover is. So there are better options for that, and we'll get to that in just a minute. Let's go over locking. So locking on a coiling door. A lot of interlocks, and this is an interlock switch. This interlock switch is going to be guide mounted. If you have an operator that there is not an interlock available in the operator. So a lot of those interlocks are actually contained within the operator itself. Most of those are contained in a standard duty use operator. If you don't know what that means, standard cycles. We have standard cycles and high use cyclage operators. So those higher use cyclage, higher horsepower operators don't typically have the interlocks available. So then you would have to move to a guide mounted interlock. This interlock is going to tell that operator not to turn on while the lock is engaged in the jam. If you were to hit the button to open the door, these doors are anywhere between 600 to, I don't know, 4,000 pounds a piece. So the door essentially would try to open while it's engaged in the jam, and it would either tear the door apart or the operator would be torn apart. So this interlock switch is essential in those situations. That being said, I would say 90% of locks that are on coiling doors that have operators are not utilized. A lot of you have garage doors with operators on them, and you'll have a string with that little thing that dangles down. That's to disengage your operator from being locked. While the operator is on there, it locks the door down into place. And you can kind of see how cumbersome this is for this man to be on his hands and knees trying to get the locks to lock, which is really unnecessary unless it's a manual door. So if it's a manual door, if it's a chain hoist, or if it is a crank, then you will probably need locks on the doors. If not, you can probably eliminate those locks, or you might get an RFI from a contractor asking you to eliminate those locks. UL 325, this is going to be for obstruction detection. This is photo eyes. So we have two types of photo eyes. We'll go over a couple things on photo eyes in UL 325. On photo eyes, or sometimes they're called photo cells. It is going to be mounted 4 to 6 inches above finished floor. And it is going to shoot a beam of light, a beam across the opening, the full width of the opening. If that beam is broken, then the door is told to reset itself. If you can see in this picture, that fire truck is probably going to come out of the bay, and this bumper is probably not going to break that beam in time for the door to tell itself to reset itself. In this particular instance, you probably want 2 sets of photo eyes. Since these are mounted 4 to 6 inches above finished floor, then you would have protection up to 12 inches or a foot. Or you could have a sensing edge, and I'll go over what that means in addition to that set of photo eyes. 2 types of photo eyes. There are NEMA 1, which are, in my opinion, not appropriate for heavy commercial construction. They're a little bit more flimsy. If you don't specify one, that's probably the one that's going to get bid. And there is NEMA 4, which is this type of photo eyes, which are a lot more rigid, and they'll be more secure for the opening and definitely more appropriate for commercial construction. This is a couple things going on with this photo. For one, there is a very large operator on a very small counter door. Counter doors tend to have a smaller coiling box. Our slats are smaller on those. We'll go over that in just a little bit. But this is still the UL 325. That's a sensing edge that goes across the bottom of that door. And you can see here, this is an electric sensing edge, and this is a coiling cord that comes down all of those. If this was a full-size door, that wire would stretch from the operator all the way to the bottom of the door. So this is going to be intrusive in this particular situation. It's going to maybe obstruct some things. This is a pass-through window. We can see that from the photo. A more appropriate application for this, and for most applications, is going to be a wireless sensing edge. So a sensing edge, if you don't know what a sensing edge is, it's going to act a lot like an elevator. It's going to have to come into full contact with something before it resets itself. So if you don't want the UL 325 or obstruction detection to actually come in full contact with something before it resets itself, then possibly again have a set of photo eyes and a sensing edge. In this particular situation, this probably didn't need a UL 325. It didn't need obstruction detection because it's a pass-through window. A more appropriate application would probably have been a tube motor. On the last application, you probably would have got several RFIs for this, let's hope. If you don't get an RFI, it's like this and it goes out to bid and gets installed that way. A tube operator is an operator that fits inside the piping, so it is completely concealed within your coiling box, and you're not going to see that. On this, you can also see there is no UL 325. This is a pass-through window. You don't really need a sensing edge on something like that, unless it is a counter fire door, you might. So on the tube operator, these are made for lower duty use. So in construction, what we call, and we'll go over this during high cycle application, lower duty use is going to be anything that is 9 cycles or under. So that's going to be low use. Small to medium sized doors, we're going to go more on the small side, which is going to be 120 square feet or under. If you get a door too heavy and you were to put a tube operator on it, it's going to burn out pretty quickly. But then also you might put your finger on the button and it might take 10 minutes to open, which would get probably a little bit cumbersome. So aesthetic appearance, of course, you're not going to have that big, large operator hanging off the back of a small door like we saw in the previous picture. And then those pinch points are going to be eliminated too. You're not going to have those because this is going to be concealed within your application. Application appropriate products. So and it was before this, we have seen a large uptick in behavioral health patients, and utilizing standard rooms to facilitate behavioral health patients is a little bit challenging. If you've been in a hospital room, we all have, there are counters behind this. You're going to have cabinets, countertops, and there's going to be things in those cabinets. And we want to try to protect not just the patient that is being treated, but also whoever is treating the patient as well. Our nurses and doctors, we want to make sure they are safe and they're not going to be able to get to anything that are in those cabinet areas. So a couple things we look at is going to be always on, no matter what application that you're using, we need to look at your gauging, and we're also going to have to look at your finishes. Aluminum would be fine. I suggest stainless steel on these applications. They are going to be exposed to things like biohazards, maybe bodily fluids, and also cleaning materials that we would need to protect that finish of the door from. Other thing that we're concerned about on this, and if I was in your office, I would ask if anyone noticed anything different about this application. So for one, since you have a cramped space here, you're not going to have a whole lot of room to have your setbacks for your guides. So we're going to set those to tubes, to the face of a tube. And this is also going to have your coiling box on one side, and then your operator is going to be on the other side. And those will be installed above a finished ceiling. Again, we don't want patients to be exposed to any pinch points, any of the bolts or nuts that are here. And then your key station would be mounted on the outside of the room. Another thing I get a lot of questions on, or I see a lot of oops, are going to be for clearances. And some things that are missed on coiling doors, and the requirements for coiling doors, of course, are different than sectional doors. This is going to be a part of the presentation, and I'm just going to mention sectional doors briefly. So on a coiling door, we have, and I cut this off on accident. So if I'm guessing down here, we're probably going to have about 3¼ inches for your guides. But up at the top, you can see that grows a little bit. So on one side, and this is going to depend on the application, this can grow up to 11 or 12 inches, depending on the size of the door. So this is 7 5/8 inches. And then the other side, you can see it's a little bit less, 6 5/8 inches. But that's because we have spring adjusters and operator brackets that stick out the top of the coiling box. So if you were to have side by side coiling doors, and you remembered to leave room for your guides and then forgot we had these things sticking out the top, we could run into some trouble if you didn't have enough clearance, or if your mounting structure in between didn't have enough clearance. I would say this is most prevalent in a bar and grill area if you're mounting coiling doors in a bar and grill, because there's corners there. If you have a corner, you just have to make sure that you build out that structure large enough to facilitate this, or you have enough headroom possibly to stagger these coiling boxes. Another thing I see missed a lot is this. So I was doing a project the other day and I was dealing with a engineer, and he said, no, we have enough clearance. We left 14 inches there. And you will also need this 5 inches. In coiling doors, we call that an upset. So you have 14 inches, and then you have to add this extra 5 inches. If you look down here, you always have a bottom bar. That bottom bar is about 4 inches, and then you have a stopper right here. So you have to accommodate that. If you only left 14 inches in your headroom for the coiling box, you would have a bottom bar and astragal hanging down in your opening. So this upset is really crucial. There's only so much that we can do to work with that or to alleviate that 5 inches, because you have to leave room for that bottom bar. Certain applications, counter doors have a smaller bottom bar. So if your opening is small enough, we can maybe facilitate that. On sectional doors, we have different requirements for clearances, right? So on a sectional door, we have to worry about headroom, but we also worry about back of the room. And that is on some applications why sectional doors are a little bit trickier to use. In a perfect world, we have 40-foot ceilings and we can go straight up the wall with our sectional doors, and that is best case scenario. In that instance, if you want to, and we call that full vertical lift track, if you want to go straight up your wall, you need your door height plus your door height again, plus 12 inches for your counterbalance shaft. And your counterbalance shaft is your operating system. That's what we call this up here. So you need 12 inches to allow that to operate and function properly. Headroom clearance in a sectional door, and I get questions on this. They'll say, I left the 16 inches or 18 inches, so we can use standard lift track. If you're in Florida or have a heavy door, you're going to be about 3-inch track, which is 18 inches. And I always ask people if they know what a trolley operator is. And some people say no, but you actually do. If you have a garage at home, you have a trolley operator more than likely. So the trolley operator attaches to the top section of your garage door and it pulls it to the upright and closed position. That is the operator that needs to be specified for a standard lift track, but that operator hangs down about an extra 4 inches. So you actually need about 2 feet of headroom for a standard lift track. What we don't like to see, and you might not know what a jack shaft operator is, but it's going to be a side mounted operator. On a sectional door, and this is crucial, there is a cable that runs from the bottom of the door to your drums up here. And it wraps around that as the door comes to the upright and closed position. If you had a jack shaft operator, it's going to jerk that door and try to go over that radius too quickly. And we have something called cable slacking, and your door can actually free fall if you have too much cable slacking. So the right operator has to be specified to the correct track configuration, and your track configuration will 100% depend on how much clearance you have in your headroom. If we're talking about back of the room space, if you have standard lift track, you are going to need your opening height plus another 25 inches to the back of the room. And that's for that trolley operator track system to pull that door to the back position. So essentially you need about 2 more feet of clearance. So if you had a 10-foot opening, you actually need 12 feet of back of the room space. One option or one product that can alleviate that, and there's several on the market. This is a vertically stacking door. So if you need vision, and this is really a hybrid between a sectional and a coiling door, this is going to stack in your header. You can mount this above a finished ceiling, or you can also um, just have this below ceiling. Some people like the more industrial look. We'll see these a lot of bar and restaurants. And we have a residential version for this. We only had a commercial for quite a long time. There were some pinch points that we needed to address to move it to residential, but that residential model is available now. And this is just a photo of the same door, but installed where you're going to kind of be able to conceal those guides a little bit more and give it a better, cleaner look. This does not have the covers over it. We do have cover options for this. I had that question one day. So that is one option. So parking and clearances. Parking is one that I do get a lot of questions on, but not just questions. I have sat in owner meetings because their doors have worn out quickly, and we're going to go over cycle counts. I would say on coiling or sectional doors, knowing your cycle counts, and this might be something you have to go over with owners if you even have a question about how many times the doors are going to be open and closed. A cycle is the doors open once and closed once. That is one cycle. We'll go over the clearances first. The other thing that we think about in parking garages is going to be your clearances. We have ADA requirements, and then especially if you have maybe a parking garage that is below grade, we start to get into some clearance issues there. From doing projects with parking facilities, if you have a door like this, but you only have one grill that is going to be utilized for cars coming and going out of the same opening, you're probably going to be anywhere from 24 to 26 foot wide. And I know from experience that your coiling box is probably going to be about 24 to 26 inches high. Maybe you have clearance for that, maybe not. These look like they are partitioned off, and these are separate grills for entering and exiting. So these are probably anywhere between 16 and 18 inches high would be a guess. If you come into clearance issues, there are options. And I would say even after going into bid phase, before drawings were submitted, there would have been, we've run into clearance issues and it's already gone out to bid, and a lot of RFIs are sent out because the door is actually not going to fit. If that is the case, we have options on the market, or there's options on the markets for low headroom clearance. That is accomplished by having really large, not really large, but larger links at the top, and it kind of gradually goes down, and where your smaller links are on the bottom. And that is going to allow that curtain to coil really tightly on itself. If you originally had a 24 to 26 inch coiling box, this is going to cut those clearance requirements in half. And you'll now be down between 11.5 to 12 inches. So maybe you have more clearance now.
Hey, Megan.
Yes.
Hi, just real quick, that we have a question. I'm not sure if you're going to be covering this or at some point, but so
Sure.
we're got a question from Donna asking about the wind speed design for doors and windows, and are there places where doors with windows are not allowed?
Yeah, I'm going to get in. It's closer towards the um, end of the presentation. We're going to go over wind, but yes, when we get into wind, it's different. You're going to depend on if you're going to be a coiling door or if you're a sectional door. And we'll go over, I don't think I go over wind-borne debris. I have a presentation just on wind loading, but in those wind-borne debris areas, you definitely need impact rating for anything with glazing. So if you are a mile from the coast and it's 130 miles per hour, or if you are 140 miles per hour over and you have glazing on your doors, then you need impact resistance for those doors.
Okay, and then another question just came in. It says, do you have Florida product approvals for the Vertistack doors?
We do, but right now it's only up to negative 27 PSFs. It takes a while to get Florida project approvals and NOAs. I know we have, and I'm expecting those probably around Q2 that we're going to have the 40 PSFs that covers majority of Florida. Those aren't in yet. So right now we're at Florida project approvals are at negative 27 PSFs.
All right, you're caught up.
Okay. So cycle counts, and I will kick this dead horse a lot during my presentations because, again, I have sat on owners meetings with clients, with my architects, because they are unhappy because the doors wore out quick, and we're going to show you how to avoid that. And this will avoid a lot of RFIs too. We're just going to take parking facilities because sometimes these are high usage as an example, but this can be anywhere. We consider high cycle construction. We went over what we think low cycle construction is. High cycle construction is going to be any door that is utilized 20 times or more a day. Then we start thinking about different model numbers because what your parts and pieces it'll break on those doors. First, it's going to be your springs. And then second, it's going to be your operators because operators should be specified to your door cycles. On a standard coiling door, you're going to get 50,000 cycles standard, and you can go up to 1,000,000 cycles. So knowing how many times those doors are going to be open and closed per day is really important. If you're taking parking facilities as an example, there is no science to what the correct cycle specification is going to be. What I tell people is that car, if it comes in, it's probably going to leave, or if it leaves, it's going to come back. So that's 2 cycles per parking space. And that'll give you semi idea of how many times that door is going to be open and closed. Sometimes the door is just open during the day and closed at night. In that instance, you would not need a higher cycle construction. If it is open continually, here's what happens, and it's pretty simple math. This is just stating that sectional doors are not made for higher cycles. So on a sectional door, it's different. You're going to have 10,000 cycles, and you can go up to 100,000 cycles, but 10,000 is standard. That's where you start, as opposed to a coiling door that is 50,000 cycles standard, and then you go up from there. So let's see here, just to put it better in perspective, I'm a visual person, so 50 cycles per day times 365 days in a year. You can see if this door is opening and closing 50 times a day, you're putting 18,250 cycles per year on that door. 50,000 life cycles divided by the 18,250 cycles per year you're putting on it, that door is probably going to wear out in 2.75 life years of the door. I've had this happen on projects, and my architect will come back to me and say, I specified this door a couple years ago. They all wore out. What happened? And I had an ambulatory center up in the Carolinas, and they had to replace all the doors. And it was about this exact time frame, 2.5 years. That's why I use this, because they were cycling the doors 50 times a day, and the doors wore out when they were going to. The owner was unhappy. So if we're going to go to 1,000,000 cycle door, you're probably going to upfront, just for a guesstimation, about 20% more, but you're getting a 1,000,000 cycles compared to 50,000 cycles. So the 20% really isn't that much more when we're considering the life cycles and lives of the door. All components, this is just saying all your components, and I think it's alluding to this. When you go to master specs, and I see this in a master specs a lot, I had this just the other day that there was a question from one of my architects saying, is their operators actually matching their door life cycles? And no, they weren't. So they had a standard use door, 50,000 cycles, and the master spec for the operator was over 90 cycles per day. So you had a high cycle operator with a standard cycle door. Those two didn't match. So all your components should match each other. And I know master specs are hard with coiling doors because there's literally thousands of options for coiling doors. and how those specified will cause those high rates of RFIs because they are hard to kind of contain all the options in one master spec. I don't think it's possible, but if you need to change those around a little, I would say this would be one area that you should look at and make sure your door life cycles match your operators as well. And vice versa. I have seen it the opposite way, and there is a higher cycle door. Let's say they bumped that up to 100,000 cycle springs, but they used a standard duty operator. Well, your operator is still going to wear out before your door does. And we want to make sure that everything kind of uniformly wears at the same rate. Cycle count on a sectional door is really important for a couple reasons. This is a fire station. I get a question a lot. Why are the bottom sections solid quite often? And that is because fire trucks, if you think about what their job is, they are going to be rushing out of the bay as fast as possible to get to whatever emergency that they need to get to. At times, they cannot see that bottom section and they'll hit it. If I'm doing a specification on a fire station, I'm going to put LED lights on either side. When they are green, that tells the truck they are clear to leave. The door is fully in the upright position. And when they are red, they are in the down position or still opening. In reference to cycle counts, and if I was in your office, I would ask you, why do you think there's 2 shafts here? And sometimes people get it, some people don't. It is for redundancy. So also think about how many times a day in, let's say, a medium to larger city that these fire trucks are coming and going every day. That door is going to be cycled a lot. Unlike a coiling door, you don't move to a different model number. Well, we do have one other model number. There is a couple on the market. But on a standard, you can go up to 100,000 cycles. But once you get to about 23 to 25,000 cycles, you're probably going to come out with an extra shaft. Each one of these shafts will account for an extra 12 inches of headroom clearance. So that is just something to be aware of when you are doing specifications and those cycle counts for sectional doors. They do differ from coiling doors. All right, let's get to wind. If you're not familiar or don't know where to find your wind pressures, if you go to your structural page, and I would say in Florida, wind pressures are probably one of the larger RFIs and questions that I get questions for, especially if there is possibly an architect that is not as familiar with Florida building codes and they're still specifying in Florida. So this is good information. We are located, or doors and windows, we are components and claddings. So if you go to your structural pages and you're trying to find your PSFs, you're going to want to look at your components and cladding area. So this is just stating, if you look at your components and cladding area and it gives you a PSF, look at what it states next to it. Are they calling this out? And I would say most of the time they're going to be calling these out in what we call ultimate design pressures. That's what our wind speed maps are, an ultimate design, VULT. What we do doors and windows to, because of our testing, is going to be nominal, or VASD, allowable strength design. That's how garage doors are calculated. So if you have, and I would say I see wind pressures in Florida and other places, especially North Carolina, that are over calculated for wind pressures, and that's going to add a lot of cost to your project. And also the options that you have as your pressures rise, your options for doors lowers, especially when we're talking about sectional doors. If you're talking about a coiling door and you need impact rating, you cannot get glazing on those. You can't get vision panels. You can on sectional doors, but your options of what door models you have substantially get lower as those wind pressures raise, because they have to not only be able to withstand your wind pressures, we also have to withstand that impact testing that all doors and windows have to go through. This is where it says in Florida Building Code that you are allowed to multiply that, and that will take your ultimate down to BASD. This is going to be 0.6. So if you look at your structural page, it says ultimate wind loads. And let's say you are at, it looks really high to you, it's 75 PSS, but that's ultimate. If you multiply that by that 0.6, you'll get your actual pressures, and you can kind of lower those. You'll have more options, and it will also lower your labor cost as well. And we'll go over why that is. So coiling doors, on average, so if you're on the call and you're not in Florida or not in a wind loaded area, your coiling doors are still going to be manufactured to about 20 PSS wind load. Higher wind loads, we have to start thinking about different components. I've been asked a lot, why is it so expensive to build in Florida doors? And that is because we have whole different components. Our steel gauging is different here. So this is a wind locking bar. Every slat will have this, and then there is your wind lock. That is going to keep that within your guides. So that is the main purpose of a wind-loaded door, to be able to deflect with those pressures that are found in the storms and still stay within the guides. This is on any coiling door. You are going to need, and I do get a lot of questions on this, on your jambs, you are going to need structural components that are from floor to either structure above or floor to a structural component that is above your coiling box for bracing. So you're going to have dead loads and live loads. If we're talking about wind loading, this is your spacing. So if you're talking about labor, it is more intense and it is more costly to build in Florida because of this. So as your wind pressures raise, your bolt spacing is going to get closer together. So if you think about it from wind loaded area versus a non-wind loaded area, maybe you're bolting in or drilling in every 24 inches on center for a non-wind loaded component, let's say 20 PSF is standard, to a non-structural component. To in Florida, you might be drilling in every 8 inches on center to a structural component. So your labor is more intense here. So again, to keep your costs down, make sure that those PSFs are calculated correctly. But you also don't want to underestimate those. Your dead load is above your opening. Your live load is below your opening. When wind pressures hit the front of that curtain, we call that static pressure. It is going to defer all of those pressures to each guide. So it's going to be split 50% in each guide. So let's say you have 20 PSFs, it's going to add 4,800 pounds of loads to your jambs, and it's going to be split in half, half in each jam. High velocity hurricane zone, which is Miami-Dade, Broward County, you're going to add probably 14,400 pounds. So it's really crucial, again, not to underestimate your pressures as well. We want these doors to be able to withstand those pressures. Operable wind loads. I will tell you now, I see this misspecified or specified in Florida, and it should not be. I have seen doors that are specified to 50, 60 PSFs, and in the specification, it says doors should be operable to specified wind load. You do not want to open a door if there are 140 mile per hour winds outside. Plus, to be able to do that, operable wind loads, and you can do operable up to 20 PSFs, not in Florida. Anytime you go over 20 PSFs, you can't do operable. So there are things. So static pressure is going to be when those slats kind of get bound up in the jambs. When you get all that pressure towards putting pressure onto the curtain, it binds up in your guides. So that door is not going to be able to fall out or drop out or descend or ascend properly because it has too much friction. So what we have to do to those doors to be able to create that operable wind load would be add extra components to it, just like those wind locking bars. But now we're going to have rollers. It's going to negate that friction that we saw, and you're going to be able to get that door to the upright and closed position. We'll also have a heavier curtain. We're going to let the force of gravity kind of pull that door to the down position. So that's available up to 20 PSFs. When you go over that, it is not available because these rollers and components not withstand our impact testing. So we have to do for our Florida doors. Let's go over finishes. In Florida or anywhere where you have a lot of moisture, if you have specified coiling doors enough, you know, they tend to scratch, especially in your top slat. So we have components up in your coiling box, gears and so forth, that will tend to scratch those a little bit. So extra protection on your doors, I would say as an industry standard and specifications, powder coating is pretty normal. If you look at the difference between just plain baked on enamel and galvanized, you're going to have 0.8 mils. And then down here on your powder coating, you're adding extra protection. That's 0.25 mils. If you are in an area that has high corrosive environments, or if you are really close to the coast, you want to think about going above and beyond that. If you go to a high cycle door, because those doors are cycling more often and at faster speeds, you're probably going, it will automatically come up with a higher graded finish. So this is going to be a powder coating, that 2.5 mils with an extra layer, an orange peel that is done in-house. And you can kind of see there's textured here. It's a little bit glossier. It's ran through 1 million cycles and it holds up much better. So anytime where you have aesthetics as a main issue, corrosion, you want to think about protecting that door a little bit more. If you have high corrosive environments, inside or outside, stainless steel, there are model numbers that will protect against corrosion. A few things that we do to that, there's a ZRG, that's a zinc coating that we'll have to put on your brackets. So people will think about the curtains, they'll think about your hood, and then there are components, other components. Your guides probably need an extra coating, your brackets, maybe your bottom bar, but also your operator. NEMA 4, this is going to be weather and water resistant. Also, it's going to be designed for continual use, and it's going to help with corrosion. You see the hood here is rounded. You probably don't want a square hood, especially if you're mounting exterior. You don't want snow or critters or anything making a home on a square hood. So if you mount exterior, remember to put a round hood on that. I'm going to have to start talking faster. Mounting conditions. Okay. If you are mounting to steel jambs, this is what, and we are very complex in the door world here. We call this an E-guide because it looks like an E. So that is going to be for steel jambs. It can sit closer to your corner or to the opening. Face of the wall Z-guide, again, very technical. It looks like a Z. This is going to be used for masonry construction, and we see this a lot in Florida because it has to sit away from the opening. You do not want your attachments or your guides too close to the corner because those will put stress on your corners and they will tend to crack. So you would need a Z guide. For masonry, you can have that E guide that sits closer to the opening if you have a steel structure that you are mounting to. See here, it sits back from the opening a little bit. Letting your contractors or your manufacturer, if you reach out to your manufacturer's rep for coiling or sectional doors, and letting them decide what structure that you need. If you're not in Florida, steel tubes, you would have to have your engineers calc that out. But if you aren't, steel tubes are a great way to mount these doors, and it is going to be less costly than structural C-channel. So this was one that was a proposed idea, and it will save cost. If you have the GC set your structure for your jambs as opposed to your door installer, if those are set even an inch off, and I've seen it happen on sites, they'll have to be taken off and reset. These coiling doors need to drop and they need to be level. So having the door contractor set those is probably a good idea in most circumstances. All right, I'm going to go through this quickly. Master specs, so temperature rise limit. There's a couple manufacturers on the market that did a really good job at putting these in all master specs. It is typically not needed. So in an exit area, these are only going to be needed. Temperature rise is only needed during when there is no sprinkler system. So sprinkler systems will negate the need for that temperature rise. So it's in a lot of master specs. Is it needed most of the time? No. Okay. Mounting for a full-size coiling door versus a counter door. On a counter door, you can use wood studs. You can mount this to back-to-back 16 gauge metal studs in areas that are not highly wind loaded, or if you are in an interior space, this is a great option. So if you have a counter door, you can, as long as your opening is 10 foot or under, and you're under that 120 square foot, you can use a counter door as opposed to a full-size coiling door to protect that opening. Your full-size coiling doors are going to need 3/16 inch thicker steel or some kind of structural support for those. So you can see our guides there are different for the full size compared to your counter shutters as well. Full larger fire doors, and this was a project that I worked on. You can see this is 34 foot wide by 40 foot tall. And originally this was 42 foot tall, and we had to say, no, we can only go up to 40 foot. Things that are having to be done for these UL classified doors that are very large or oversized. This particular door, if you're going to go drop test this, a UL representative would have to come out, drop test it. It's going to be thousands of dollars to drop test each door to make sure it falls out. In this particular project, they had to have these doors this large. But you can see here, before you had a 5-inch upset. We call this area here from the opening to the bottom of your coil box an upset. This is 9 inches, not 5 inches. And that is on very large or wide doors. You will have deflection. It is just unavoidable on really large, heavy doors. So we have to compensate on this upset for your deflection, but then also, again, that bottom bar, because we do not want anything hanging in the opening or any air, especially on a fire door, to be able to get through the opening. Mounting above a finished ceiling, doesn't matter if it's fire rated, doesn't matter if it's a standard application, you need to leave at least a 4.5 inch slot for that bottom bar to be able to drop out of the ceiling. So that is one thing that I've seen missed, that it is pulled in too far and the slot is not left open that is wide enough. Activation systems, again, I'm going to try to talk fast. A fusible link versus automatic release devices. And I do get a lot of RFIs. We see a lot of RFIs on this when it comes to fusible links. This is a fusible link. It's going to melt at a rate of 165 degrees Fahrenheit. It is going to be released. The door will be released by a chain cable arrangement. Anyone that has worked with fusible links enough knows when the door comes down, it just comes down. We call it the guillotine effect. These doors by code have to drop 6 to 24 inches per second. It's very fast. If you think about how heavy a coiling door is, we're talking anywhere from, I would say standard, probably 1,600 pounds just coming down. These can be interconnected with an alarm system or a heat detector. Whatever the case is, this is a fusible link. And once that's melted, it just comes down. If you interconnect that with a release device, if it has smoke sills or is in an area that needs smoke sills, then it has to have an automatic release device, meaning it has to be automatically dropped by some sort of activation, whether that's a heat detector or a fire alarm. So if there is a false alarm, the door is still going to come down. If there is human traffic or pedestrian traffic coming underneath or going in and out of that opening, just know that a fusible link will not detect any obstruction. It will just come down. If it's in the path of egress, you will need smoke sills. So this cashier and attendance area, they would need smoke sills on these. That means they would have to have this release device if they had fusible links. Once you put this on it, if it has smoke cells, I would say move to an advanced system because you're going to be at about a wash to go ahead and use that advanced system either way. So here's that system on a fusible link. You're going to have your fusible links. You're going to have your chain or cable arrangements over here. It'll be interconnected with a smoke detector or some sort of system. Then when that is activated, the door is going to drop. You cannot use that door until someone comes out and resets it. A professional will have to come out and reset that door. Advanced systems will be an alarm system. And once you put these alarm systems in there, they can be interconnected with a automatic release. You can put them on, interconnect those with an alarm system or a heat activation device. The door will be triggered. It will come to the down position. If there's an obstruction below it, it will reset itself and come to a safe rest until the obstruction is moved or cleared. This is a very safe system. To reset the door, you push a button, it goes to the back to the upright position. If budgetary issues are a concern, I would say leave the powder coating off the door if you're not going to see the door, only in emergency situation. If you're mounting above a finished ceiling and you can conceal that door and add an advanced system, you will probably be about even for including this. And again, this is a much safer approach when we're talking about fires. And fires, aesthetics should not be the main concern. Safety should definitely be the main concern in those instances. This is just going through the regulations. Again, automatic closure should have activated by an alarm system. We went over that. Closing speed of not more than 9 inches. So some are a little bit faster than that. Most manufacturers have governors, so it doesn't drop faster than that 9 inches. And then if it does and it's on a spring tension or on a fusible link, someone will have to come out and reset those. And until they're reset, those doors are not usable. So again, all of these things that we have gone over, creating a good specification in early design phase is pretty important. It'll avoid all of those RFIs. And I know, again, with coiling doors, sectional doors, there's so many options that it is hard to kind of encompass all of those in a master spec or into a specification. So again, we provide that. We are always available for questions or to do a project assistance with you, get you all of those correct details. We would just ask for some information before we work on your project and kind of work through that together and provide an accurate spec. And I left 5 minutes, but here is my contact information. Again, I'm in the Southeast. If you're not in the Southeast, I follow my architects where their projects are. So if you're located in Mississippi, but your project's in Puerto Rico, I would still be the one to help you. And if you're not in the Southeast, I can find your rep for you and kind of put you in contact with them. But this is my contact information. If you want to take a screenshot, and I'm not sure if you have any questions. We've got about 5 minutes left.
Yeah, Megan, there is one that just came in. It asks, do you have options on bottom bars that are not the double angles?
We do. So I would say most common is going to be a piece of extruded aluminum. If you have a insulated door, if you're doing air infiltration, you're probably going to have an insulated bottom bar. We also have a bottom bar that's impactable or impact resistant. So we do have several options for those. Double angle bottom bars depends on how wide your door is too. So if you have a door that's over 20 foot wide, 21 foot wide, it's going to come out with that double angle bottom bar though. So it depends on the size of the door, what's available as well.
All right. Actually, that was the last question. We'll see if anybody else has a question within the next minute or two, just in case.
Right.